Good afternoon, everybody. So let us start our class. So we were discussing threads and multi-threading programming. We are discussing multi-threading programming, right? So let me do a quick review. As you know that a thread is a program's execution path, and in our normal program, we do have only one thread, the main thread, that is called the main thread, where in which the main method exists. Okay, but in addition to the main thread, we can have multiple threads or multiple execution paths in our program or application, so that we can execute multiple modules concurrently. Okay, so this is the block diagram of a multi-threaded program. That we will have a main method, so where the main method is, that is called the main thread, and the main thread can run other threads like thread A, thread B, and thread C, and we can switch our execution from one thread to another thread, and today we will discuss that. This is called thread management. But let us do a quick review. That we know that there are two ways in Java to create a thread. Number one is by extending the thread class, and number two is by implementing the runnable interface. So by extending the thread class is the easiest way to create a thread. Just you will write your thread class, okay, and you write your thread, and then you will extend the thread class, and you will write your run method, and this run method is the starting point of your process, or your whatever you want to execute in this thread. And within the main method, we use that thread. Okay, a thread is like we are defining a thread as a class. Like a thread is a path, that means a stream. Consider that as a stream, is a flow. Or if you compare a thread with a highway, that you can consider that a thread is a lane. So we may have multiple lanes in a highway like this, and then when we have a thread, then we can, that means when you expand a line, a road, then you can make an extra lane. So then that means this is the expansion here, and then when you expand this your road, then you can draw some curves or lines, and then it will get a new, what is that called, lane. That is like this concept. And then we call start method. The start method actually calls the run method. That is the simplest way to create a thread, and there is another way by implementing the runnable interface. By implementing the runnable interface is a little bit tricky than the extending the thread class. So here we will implement the runnable interface, and this is here is same thing, but the trickiest thing is here. Okay, so we will create an object of this thread but we cannot use this object directly to call the start method. We need to create another thread object, and while creating the thread object, we will pass this object into the constructor of the thread class. That is the trickier thing. Okay. So, for instance, this is a simple program. This here is class my thread, extend the thread class, and it has run method, and it is the main method. Okay, so we discussed similar program in previously, but let us do this one. We can maybe create this one another program. Okay, there are errors in this program. Let me try it. It works. Okay, main thread demo. My code is here. Okay, and I need my thread. Actually, it is getting my thread from somewhere else. And to the my thread. Okay, so here, okay, you okay, my thread somehow is already exist. So let me make it my thread as 0 and my thread 0, my thread 0. Okay. You know that in on Java program we can have multiple classes, but remember that this is the starting of this class and ending of this class. But remember that in Java you can have only one public class. In one of your test you wrote multiple classes, but you put multiple some of you put all of the classes as public. That is not a good way. So if you want to make this class public, you have to save it in its own separate file. So only one class can be public class, and the file name will be saved by the public class name in C#, in Java. And in C# we use namespace. I will tell you later in C#. So this program, if I run this program, actually it will print some stars actually. Okay. I'm going to explain this program what happens. Okay, the program is running, that's good. I will explain this later what happens. Okay, so far we learned that in Java there are two ways to create a thread. Number one, first way is by extending the thread class, and number two way is by implementing the runnable interface. Okay, again I am repeating that is extending the thread class is the easiest way and straightforward, but implementing the runway interface is a little bit trickiest format, where we have to what is this method? We can create an object directly, but this object we cannot call this. We cannot use this object directly in order to call the start method. We need to pass this object to the constructor of fetch class as an argument. Then by this object we can call this start method. So this one line is the actually these are the two. Actually there is an extra line over here. This line is an extra when you implement the runnable interface. So everybody understand? Anybody has any question so far? So if you remember until this, if you understand until this, so from here we want to switch in C#, because the C# way of creating a thread is a little bit complicated, and it follows the way that most likely that Java uses the second way by implementing the runnable interface. So this is almost C# use almost this similar way, second way. Okay, so people who are taking C#, please give emphasis here, over here, give attention here, because this will be your foundation for your C#. Because this line, you see that this line, we are creating this line as maybe an extra, okay, and then we are passing this object, is the object here we are passing. This is in Java way that implements the runnable interface, and this is the similar way in C# that we will use in C#. Okay, so let us see some examples in C#. Okay, multi-threading example 1. So let us go to this example. Okay, so in this project, the project name is multi-threading example 1, EX1. So we have our main, we have our program over here. You see that in C# we have namespace. Okay, so within namespace you can have multiple classes. But if you like, this namespace is like more likely a package in Java. Okay, so here with the main method, so this is my main thread, and within my main thread I have created a thread. Okay, this is my main thread. This is my main thread. Okay, and within main thread I'm going to create a child thread. Name is child thread. New thread is called child thread. Okay, the creation of a thread is more likely with Java. How we, as I told you, that how we use the runnable interface. Okay, so here we will use thread class. This is a built-in class in Java within Java.system package threading. Okay, and then we will write the thread class name, and we will call the thread constructor, and within the constructor we will pass the child. We have passed the child reference over here. The child reference is what we see. That remember this line. Give attention to this line. Can I highlight this one other way? So how this line is working. So here we have another class is called thread start class. We are creating a thread start object. This is called child reference object, and in the thread start constructor we are passing this like an interface. Okay, so we are giving this like is an interface, and within the interface whatever I want to execute my programs, this is more likely in Java, like in Java, like Java run method over here. This is the format. Okay. In Java, we use run method in order to run your code. But here we are putting that in a constructor like interface. It is called interface or constructor. I will check, and then I'll let you know in next class for sure. So this is the way it is one line. This one line is different. So by this way, what will happen? This child thread will start. Call the start method. When you call the start method, this start method actually it will actually call this call to child thread. More likely this thread method is likely calling the run method in Java. It's similar way. So then if I run this program, what will happen? Can you guess that what will be my output if I run this program? People who are taking Java lab, please raise your hands. 1, 2, 3. Okay, a lot of people. Okay. Now try to understand. You should be able to understand. Just let me. There are only 3 consoles, right? 3 output, console output. Okay. Try to understand that which this line will be executed, will be outputted first, or this line first, or this line first. So our program, by default, our program starts from the main thread, right? Okay. So then it should start from here. This is then the main thread. And after that, when it comes this line, then it is calling this thread reference, and thread reference is calling this more likely the run method over here. Then it is going to this. And it will be nice if I put another console over here. If I say thank you over here. So let us run this program and try to understand the sequence of execution. Do you see something different that you expected? So it's okay that our program, let me do this way. Okay. It is okay that our program started with my main thread, and this is the first executable line, writing console on console that in main creating a thread cell. So this line is executed first, and after that my control went over this thread class, new thread. So it ran this line, child thread start. So this is child thread start. Okay. After that, what did I expect? Did you expect that this line will be first executed or this will be executed first? Okay. Even when I initially first time I was learning multi-threading program, I like you I guessed that I thought that these methods will be executed, the entire method will be executed first, and after that it will come back to main. I thought that after the child thread starts, it would print this line, press any key to exit. After that, it would print thank you. Okay, but it did not happen. So let us run this program again. You see. So what do you think this time output? Anyone please help me? Are you giving attention? Do you see something different in your output this time? Because there is no guarantee, I'm going to tell you that there is no guarantee that the sequence of thread will be executed sequentially that I put in my code. Yes, threads execution are random. So how many threads are there here? Two threads, right? The main thread and the child thread. Which one is the main thread? The main method. This is the main thread where I have the main class. This is the main thread, okay? Now is the main method. And I have another thread with this. Okay? So if you run this program, you see that sometime if I, so you remember the output, if I run this out program again and one more time, I'm trying to see that what happens. Okay, so okay, the first time if you would get out this output at the first time, then you would thought that okay, this is okay, my program is like more likely as a single threaded program, right? There was no guarantee that I was expecting at the first time that I would get this output. This output seems to be pretty straightforward, right? Yes. Is randomly decided, but there is a way to to decide or to control the threads. That is called thread management. We will learn this today. But what I'm going to tell you that did you notice that the execution sequence is not fixed, right? So far, by default, we do not have any control that which line will be executed first. So here, this time it is good, right? The child, so this line executed first, then it moved to this method, child thread start, and then press any key to execute, and after that it comes here. But I would be happy if I would get this sequence of output every time. You know, remember this sequence of output? let me get a sleeping output, because I run these programs multiple times. I rarely got this output. Okay. So if I run it again, okay, you see that now. You see that, right? You got this different output. This output is different than our previous output. My previous output was yeah, my previous output was this. Okay. My previous output was this, and this output is this. So we understand that. Now we are sure that there is a variation, or there may be a variation in the output sequence by the order the thread executes. Okay. So we will learn this through that is called thread management. Okay, so let us go to our next project, that is called managing threads, example 1. Okay, so this program has a few methods to control a thread, like at least one method. I see the sleep method. Okay, but before I describe this program, I need to go back to, I want to go back to my slide. Okay, before we discuss that, we need to understand something more that is called thread life cycle. Okay, a thread has 5 different states, okay, throughout its life cycle. The first state is called a newborn state. When you create a thread, that is called a newborn thread. Okay, so you need a newborn thread cannot do anything unless you start that thread. So far we have seen that we can start a thread by calling the start method, right? Okay, so when you call a thread when you start a thread by calling the start method, it goes to the next 2 states. It's runnable or running. Okay, this is these 2 states are called the active states. Runnable and running are the active state of a thread. Okay, so runnable means it is ready to be running. It is ready for running. Okay, that is the situation. Is called runnable. And running, that means a thread is running. And runnable means is ready, and it's ready, is created and ready for running. And there are some, okay, so these 2 states, and A block state is the condition when you suspended a state. You suspend a state from its active position, or that means from running or runnable state to the block state, or suspend it. You suspend it for a certain amount of time, not forever. That is called block state. And if you think that your thread is no longer needed, then you kill that state. That is by calling the stop method. Okay, so that is called a dead state. A dead state cannot be retrieved, cannot be reverted to either as an active state or as a block state. Dead is forever. But if your state is blocked, then you can resume it, either as a runnable state or running state, as an active state. Okay, so have you got an idea about the different stages of a thread life cycle? Yes.
So does the thread have to go from block to dead, or can it go from any position?
No, a runnable thread, an active thread, you can stop an active thread. You can kill a running thread or runnable thread directly.
Okay.
You see the sequence, when even if you create a state, then you can use the stop method to kill the state. When a state is in active state, then you can use the stop method to kill it. Or when it is blocked, then if you think that you don't need that one, then you can kill that. Yes.
So the block state, right?
Yes.
That means it's paused? Or,
Yes. That is paused. That is suspended for a certain time. There are two methods. In order to manage these sequences, or changing a state from one state to another state, there are some methods. There are some existing methods in the state class, in both Java and C#. We need to use those existing methods in order to handle our life cycle of state of a state. Yes. So far you have learned how to create a state, right? Everybody understands that, right? How to create a state. Okay. So that means, in a nutshell, what is your summary? That a thread has five states in its life cycle. Life cycle means by the time it is created and by the time it is killed. Okay, the newborn state just created a state, and then that state can be activated by calling the start method. And when a state is running, you can call that, you can make that state in a runnable position by using the yield method. Actually, I'm going to say that you are maybe already familiar with some methods. For instance, the start method. At least the start method. That there are some methods. This start method is one of the methods that we use for thread management. There are some few other methods, that yield method, that sleep method, stop method, resume method. We will see how to use some of these methods in order to manage threads. Okay. And there is also another method. This is called priority method. You can set a priority of a method of a thread that it will be. Then you will set up which thread will be executing first, and which thread will be executing next, which thread will be executing next. And you can set a priority with a higher priority or less priority or medium priority. Okay, so these are a few, a list of few classes that are built in the thread class. For instance, one of the class is get name, start method, run method, sleep method, EL method, join method, is alive method. If you do a Google search, then you will get a list of all of the thread control methods, and in the book has this, okay, list. Okay. So far we have used the start method. Okay, this method will start a new thread to execution by calling the run method of the thread or runnable object. Okay, the run method, what it does, the method is the entry point of a thread. Execution of a thread starts from this method. So we are familiar with this start method and run method so far, right? And a sleep method is used to suspend a thread for a certain amount of time. Time duration is okay. So let us see the sleep method. We have an example of sleep method. What do you have an example of sleep method? Okay, in C# I have a sleep method. Yeah. These methods are almost same in C# and Java, but I got more resources in Java than in C# book. C# book has only a few description, and I did a Google search. I see that Java has more robust multi-threading programming what is features than in C#. Okay, let us see this method. So here, this is my call to child thread. Okay, this is more likely the run method in Java, and within this method I am just printing this line, and after that, before I run this one, actually not this one. Okay, child thread resumes. This one actually I'm waiting. This is in millisecond. 10,000 millisecond means 10 seconds. Okay, so please give attention to the screen when I run this program. So please give attention to the screen. What do you see? Okay. It's called child thread paused. Okay, we're waiting for 10 seconds. Maybe 5 seconds is gone. 7, 8. Okay, this 10 seconds is gone. So after 10 seconds, you see that I got this message. You say in order to get this message, okay, I was waiting here for how long? For 10 seconds. Maybe you did not notice it again. Let me run it again, okay? Okay, so as soon as the screen, output screen opens, someone start counting down from 10, 9, 8, 7. Okay, who can volunteer? Johnny can volunteer?
Sure.
To count down?
Yeah.
Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, I was behind. Okay, so after 10 seconds, it came up this output, right? So that was the sequence. That was the consequence effect of this sleep. Okay, sleep methods. Okay. You see that how this sleep method is used is called thread.sleep. Actually, this is called a. Anybody remember this methods type that we call a method by its class name? What is the type of this method name? It has a different name. Anybody remember this name? Static method, right? It is a static method. The static method is called by its class name. Okay, this sleep method. Okay, so let me see if I get some more examples of EL method. Okay, so managing threads. Okay, so have you got some idea how a thread is created and how a thread is run and how a thread is controlled? You got some idea, right? We will go more in depth. So let me see if I should have another example is okay. Multi-threading example 1. Okay, all of my programs are on GitHub, on my GitHub account. So please download it from my GitHub account and then run this and try to understand, do some practice. Is it still running? Okay, it's still running. Okay, I have another project over here. It's called destroying a thread, example 1 in C#. What is stop method? Okay, the abort method. In C# it is called abort method, and in Java it is called stop method. This abort method is used in order to kill a thread. Okay. And once you kill a thread, you cannot call that thread again. For instance, let me run this program. I will show you. If I run this program, Okay, so okay, I'm almost at the end of my class, but I like you to delete to what is that called, to get this program and do some practice. Okay, then you will understand. So, for instance, if I want to give this statement here. Did you see the effect that my program terminated? What happened what happened here, after I aborted my thread, again I wanted to start that. That was not possible, right? Because at this point the thread was killed, was dead. Did I show you that a diagram that says if a thread is killed in dead position, it cannot be reverted as an active, is one way. That happened here. If I want to aborted that thread, then I cannot use that. I cannot call that. I cannot. Huh? No. Life is one time. A thread is dead, is dead. If you suspend it, so there are other methods, the suspend method. Maybe we will discuss in our next class. The suspend method, if you suspend, then you can resume it. If you send it a sleep method, then by default it will be active after a certain time. Sleeping means it will be running automatically. And if you suspend you, then you can recall it, you can start it again. But if you kill it, then you cannot, even it cannot send it to sleep, or you cannot restart it. So you got some idea? Okay, so I like everybody, so please download this program. Download this program, all of the programs in my GitHub account, in C# and in Java. Please download this, and since these are new to many of you, almost all of you, so sometimes it will be confusing. But if you run this program, then you will understand the effect. Okay, anybody has any question? We will have our next class. After our next class, we will have our spring break, right? Okay, good luck everybody.